Hello everyone, welcome back to my YouTube channel, and in today's episode I'm gonna show you how to build an AI voice assistant. The use case of this AI voice assistant is to help you figure out how to fix your Wi-Fi problems. You just need to click on the button start recording and then it will initialize the conversation with your AI assistant, and you can start describing the problem that you have with your Wi-Fi. You can ask questions and even set up an appointment if needed, and let me show you how this works. So let's click on the button Start Recording to initialize the conversation with our AI voice assistant. Hello, how are you? Could you help me please fix my Wi-Fi problem?
Welcome. To assist you, I need to verify your customer ID. Please provide it.
Of course, my customer ID is number 10.
Thank you for providing your customer ID. I've verified it. What seems to be the issue with your Wi-Fi connection?
The connection of my Wi-Fi is not stable today.
Can you describe the instability you're experiencing with your Wi-Fi connection?
The connection is dropping frequently, very frequently.
Can you tell me more about the frequency of the drops?
I would prefer if you help me to set up an appointment with the technician.
I'd be happy to help you schedule an appointment with our technician. When would you like to schedule the appointment? Please note that our available slots are between 9 a.m. and 4 p.m.
Let's set up the appointment for today at 2 p.m. please.
I've scheduled an appointment for today at 2 p.m. I'll make sure to have a technician available during that time.
Okay, thank you so much. Goodbye.
Goodbye.
So as you can see, this AI voice assistant is working as expected, and I'm gonna show you the workflow of how I build this assistant, and then I'm gonna explain step by step how to build it using Python. This is the workflow of this AI voice assistant application. So the user starts the conversation. Let's say that the user calls the AI voice assistant and describe the problem that is facing with their Wi-Fi. So an audio is recorded, and this audio needs to be transformed to text. So we perform speech recognition and we transform the audio to text using a model from OpenAI. For such purposes, we will be using the model called Whisper. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button because it helps me to create more content. Smash the like button and turn on the notification bell so you never miss a new video. And then we will have a text generated that will have the problem that the user described or the question that the user have. So after the text is generated, we will feed it to our large language model, and we will use Groq because we can get responses quite quickly. And we will specify to the large language model to check if the user that is calling is one of our customers by validating with their customer ID, and also to help them to scale an appointment if needed. So the answer that this large language model generates, we will need to transform it from text to audio. So for this, we will use a library called gTTS that will transform the text to speech. So after we have this transform, we will need to play the audio so the user can know what's the response of the AI voice assistant. And this is the workflow of this application. And now I'm going to explain you how to do this on Python. The first step will be to isolate our environment. So we will create a virtual environment which will contain all these Python libraries installed that we will need in order to create our AI voice assistant. And also we will need to feed the credentials to use Groq. And now let's go to the code. So I have this Python package already created called src, which contains all our utils and also the app.py. This is where we have all our code. So in the app.py, we have all the code needed for the front end of this application. And in the utils.py, we have some functions that we utilize in app.py, but I have it in utils.py just to increase the readability of this app.py file. And let's go step by step. Let's check each one of the functions to see what they are doing. So let's go to the utils.py, and here we see that we are importing all these libraries. The first ones are to load the credentials. In this case will be to load the Groq API key so we can do inference of our large language model using Groq. Then we import these libraries because we will need to use them in order to record audios. Then this one will be used to load the model from OpenAI that will transform the audio to text. These ones will be to use Groq. Then these ones will be to create a chain between the prompt, the large language model, and the question that the user has or the problem that the user is describing. And then we will use these libraries to play the audio. So we will transform the text to audio. Here we are loading all the credentials that we have, and we're loading Groq API key. The first function that we have here is called silence, which basically will determine if the audio that we are recording is silent. So if the audio is silent, later on we will remove it. We basically specify here that if the max amplitude of the audio is less than 3000, we will consider this audio as silent. And if the audio is silent, there's no need to process this audio. So that's why we have this function. And then we create another function that is called record audio chunk, and here we need to calculate the number of chunks needed for the specified length of recording. In this case, we are specifying that the audio will record 5 seconds, and here we specify that we will use 16,000 Hz and 1024 frames. Something that we need to consider is that the higher the amount of frames, the higher the latency. So that means that the higher the frames, the longer it will take to process this information. And 16,000 Hz is sufficient enough for capturing human voice, so that's why we choose 16,000. And then here we will start appending the frames of audio chunk by chunk. Then we specify the path where we want to save the audio, and here we specify that we want to save it in the temporary audio chunk, and then we specify that we want to save it in a mono channel, the sample rate again 16,000, and then we are also writing all the frames. And as I said before, what we do here is that let's save it, and if the audio is silent, that's where we use the function isSilence, let's remove it from the temporary file path because we will not need to process this audio. And then we proceed to load Whisper, which is a speech recognition model from OpenAI. In this case, we're using the base model. They have different alternatives. Here we can see all the alternatives that the Whisper model have. They have tiny, base, small, medium, and large. In this case, I'm using base, which has 74 million parameters. And something that we need to consider here is the relative speed. So the larger the model, the longer it will take. And also it requires more VRAM. Here we have this function then that loads the Whisper model. And then we have this function here, which is called Transcribe audio, in which we transform our audio to text. Here we specify that if a file is in this file path, and this file path is the one that we specified earlier, which is temporary audio chunk. So if a file is in this path, let's transcribe our audio to text. And then here we're saving the results of text. But if there is no audio in this path, let's return none. And this will be triggered if the audio doesn't have any sound. So if the audio has a sound, we will get a text, and if the audio doesn't have any sound, we will return none. And then here I have a function to load the prompt of the large language model. In this prompt, I explicitly specify to the model that it is an expert advisor specializing in diagnosing Wi-Fi issues. Also, I specify that the first step should be to ask for the customer ID in order to validate that the user is one of the customers of the company. And after it confirms the customer ID, let's help them fix their Wi-Fi problem. And if not possible, let's help them to set up an appointment. Something important is that I specify that the appointments need to be between 9 AM and 4 PM because those are working hours. I also specify that the answer should be concise and short. Also, if the large language model doesn't know the answer, it should say that it doesn't know rather than hallucinating and saying something random. Something very important that I noticed was that this sentence is crucial because if I don't specify explicitly that the large language model shouldn't reveal the customer IDs listed below, the large language model could do it. So before having this sentence here, in some of the occasions, I was saying that my customer ID was, let's say, number 11, and then the large language model generated a response in which it revealed the customer IDs that were in the database, which is a big problem. So that's why we have this sentence here in which we explicitly say to the large language model, do not reveal the customer IDs that are in our database. This approach does the job for demo purposes, but for production we need to perform a robust approach to keep our data confidential. Also here we specify the history so the large language model can know what were the previous responses and use it as a context to generate future answers. And then we load the large language model. So in this case we're using Groq for the fast inference. We specify a temperature of 0, so we don't want any creativity. We want to be as objective as possible. And also we're using Llama 3 8 billion parameters as a large language model. And then here we feed the Groq API key. Something also that I experienced was that the more parameters the model have, the longer it takes to produce the answers, but the answer is more accurate. So that's the trade-off that you have to face. Time that it takes to generate responses versus accuracy on the responses. And then here we create the chain that will generate the responses of the large language model. So first of all, here we load the the input prompt that I showed earlier. We also load the large language model, which we call here chat Groq. Here we specify the prompt template, which is basically prompt template from LangChain, and then we load the template, which is the input prompt. And here we create our large language model chain, in which we need to specify the large language model that we use. The prompt verbose equal true is just to see the output of the responses and also the initial question that the user asks as it is generated. And here we also specify a parameter called memory, which will essentially have the chat history. And then we invoke the chain and specify the user question. In this case, we're just returning the text of the response of the large language model. After the large language model generates the response, we need to create another function which will play the text to audio. So here we call it play text to speech. Here we specify the text that we want to play as an audio. In this case, we're using this function, which is called gTTS from the library called Google Text to Speech. Here we also specify the language of the text, and also we specify that we do not want the audio to be played at a very slow pace. So here we specify slow equals full. We save the audio in this path, and then we initialize the Pygame mixer to play the audio. We load the temporary audio file into the mixer, and then we start playing the audio. And then here we have a while loop that will play the audio until it finishes. We stop the audio, and then we remove the temporary file of the audio that was played. And now with all these functions that I just explained, we will use them in the app.py. So if we go to the app.py, here we can see first of all that we import OS, which is the operating system, PyAudio because we will record an audio, Streamlit as ST because we are creating the front end of this application using Streamlit, and also we're using LangChain.memory because here we will save the memory of our conversation, which is the chat history. Here we import all the functions that we created and that we have in our utils.py. We specify the chunk file, and here we load the whisper model. So we load the model here because we want to preload it and load it one time and not every time that the function is triggered, because this will take longer, and it's also unnecessary to load the model every time that the function is triggered. Here we start coding the title of our Streamlit app, in which we call AI voice assistant, and we specify that we want to have this title in dark blue. We create the conversation buffer memory, which is the chat history of our large language model and the questions and messages that the user sends to the large language model. Here we create a Streamlit button, which is called Start Recording, and if we click on this button, it will trigger our workflow. Here we define a while loop, and here we start defining that we want to have an audio instance and a streaming instance. We specify that we want to have a mono channel, so it's just one channel, 16,000 Hz, and also 1024 frames per buffer. Then we will feed those two variables to our function that we saw earlier, record audio chunk. So with this function, we will basically start our conversation with the AI voice assistant because it will record the audio, and after the audio is recorded, we will proceed to transcribe the audio that is found in this path using this model, which is the whisper model from OpenAI. So we will transcribe the audio, and in this variable text, it will have either the audio transcribed or it will have a value of none when the audio is silent. So if the audio is not a none, meaning that there is a message in the audio, we will create a gray box that will contain the message of the user. In this case, we specify here customer, and then we print out here the text, which is the message. After this message is printed out, we proceed to remove the audio file because we don't need it anymore. So this text that was transcribed by the whisper model, we proceed to feed it to the large language model. We feed here the text that the user sends to the AI voice assistant, and we also here specify the memory, which is the chat history. So the large language model can generate answers based also on the context of the messages that were sent before. Then here we create another gray box, but in this case we specify here the response of the large language model. We call it here AI assistant, and then we print out the response. And now that we have the response of the large language model, we can proceed to play the audio of this response. So here we use the play text to speech function that we created before that uses Google Text to Speech to play the audio so the user can know what message the AI voice assistant sent. So this will happen as long as the audio has a message, but in the cases in which the audio doesn't have a message, this condition will be triggered, the else condition, that will stop and terminate the streaming of the audio. And also it will break the while loop and finish the conversation. And that's how this application works. So let's run it now so you can see how it works. Let's do Streamlit, run, and then we specify the location of this application, which is in the src folder, and then we do app.py. and then we can run this application. And now we can see that the application is port forward to the local host 8502. That will redirect us to this web page, which is our AI voice assistant that we saw earlier. Here, if we click on this button, it will trigger all our functions of our workflow. And now let's try it out again. Let's click on the button Start Recording. Hello, my name is Eduardo and I have a problem with my Wi-Fi. Can you help me, please?
Welcome, Eduardo. To assist you, I need to verify your customer ID. Can you please share it with me?
Of course, my customer ID is number 75.
Thank you, Eduardo. I've verified your customer ID. What's the nature of your Wi-Fi issue?
The signal of my Wi-Fi is very unstable today.
Can you please provide more details about the instability, such as dropped connections or slow speeds?
I would prefer if you send a technician to home, please.
I'd be happy to help you schedule an appointment. When would you prefer the technician to visit your home? Please note that appointments are available between 9 a.m. and 4 p.m.
Let's set up the appointment for today at 11 a.m., please.
I'd be happy to schedule the appointment. However, I need to confirm that 11 a.m. is available. Can you please confirm your availability for today at 11 a.m.?
Indeed, I confirm that I'm available at 11 a.m. today.
I've confirmed the appointment for today at 11 a.m. I'll make sure to send a technician to your home to investigate the Wi-Fi issue.
Thank you so much. Goodbye.
Goodbye, Eduardo.
As you can see, everything is working as expected. Some of the remarks that I have when I was building this application were that the responses from the large language model were not accurate from time to time. So what I would recommend is to use a large language model with more parameters, such as Llama 3 70 billion parameters model, because in this case I was using Llama 3 8 billion parameters model. And also, if you use a larger model of Whisper, the better the speech recognition will be. But there you will have a trade-off between speed and accuracy. And that was it for today. In this video tutorial, I showed you how to build your own AI voice assistant, which is capable to have a conversation with you. We were able to transform an audio to text using an OpenAI model called Whisper, and with this text generated, we sent it to a large language model that helped us to figure out what was our Wi-Fi problem. And the response of this large language model was then sent to Google text-to-speech model that helped us to transform the text to audio, and we play this audio back to the user, allowing the user to know what was the response of the large language model. I hope you found this video tutorial helpful, and if you still have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel, smash the like button below because it helps me to create more and more content, and don't forget to turn on the notification bell so you never miss out a new video. See you next week.